In this demonstration, we'll measure, classify, query, and analyze 3D data. First, you'll open up a new ArcGIS Pro project with a new scene named demo_4-2 in your course demo folder. Then you'll add the building_models multi-patch feature class from your demo data geodatabase. Last, you'll confirm the coordinate system is NAD83 State Plane, California Zone 6, because we're going to be working in San Diego. We'll start on Windows Desktop, where we'll open up ArcGIS Pro. In the opening screen, under New Project, I'm going to click on Local Scene. And in the New Project window, I'm going to go ahead and browse to my course folder. And in my course folder, select the Demos folder and click OK. I'll name my new ArcGIS Pro project demo_4-2 and go ahead and make sure that Create a Folder for the local project is enabled and click OK. Once ArcGIS Pro opens, I'm going to go ahead and maximize my interface. Now I need to add some data. So I'm going to activate the map ribbon, and in the layer group, click on the Add Data dropdown and select Browse. In my Add Data window, I'm going to browse to my course folder. In my course folder, in my demo data folder, I'm going to select my demo data file geodatabase, and in my San Diego feature dataset, select the building_models multi-patch feature class and click OK. That loads my building_models multi-patch feature class in my scene. There you can see we're in San Diego, and it takes a minute to load the 3D data, but then you'll see my multi-patch features lay in. Notice they load in the contents pane under 3D layers because they're 3D objects. Now I'm going to right click in the contents pane on Scene and select Properties. And in the Map Properties window, I want to confirm that my coordinate system is NAD83 State Plane, California Zone 6. It is, so click OK. Go ahead and reset your view, save your ArcGIS Pro project. In step 2, we'll perform 3D analysis by measuring 3D horizontal and vertical distances. First, you'll use the Explore tool to zoom, rotate, and pan into Petco Park, which is the baseball park where the San Diego Padres play. Then you'll click the Measure Distance tool and measure the 3D horizontal distance from home plate to the third deck behind right field. And last, you'll click the Measure Vertical tool and measure the 3D vertical distance from the ground up to the third deck. Back in ArcGIS Pro, I'm going to activate the Map ribbon and use the Explore button and the left button to pan and the mouse wheel to zoom and orbit around Petco Park where the San Diego Padres play. So I'm going to go ahead and zoom into their baseball stadium and position the scene so that I can see right field and home plate. And now we're going to measure a home run from home plate up to the third deck behind right field. So again, on the map ribbon, in the inquiry group, I'm going to click on the measure dropdown and select measure distance and set my distance to planar feet, and then click on home plate and gently and slowly move the mouse so I can see the distance interactively being calculated all the way up to the third deck. And notice that my 2D distance is about 484 feet and my 3D distance is about 490 feet. All right, go ahead and close the Measure Distance tool. And now I'm going to click on the Measure dropdown. This time select Measure Vertical. And again, make sure my units are set to feet. And then I'm going to click on the ground and then move the mouse up to measure the vertical distance. Notice if I slide it out, it gives me a circle so that I can see exactly where I am relative to the z-axis. And I can see that it's about 70 feet up where that home run was hit. Go ahead and clear your measurements, close the measure tool. I'm going to reset my map view and save my ArcGIS Pro project. In step 3, we'll perform 3D analysis by calculating statistics and classifying by height. First, you'll zoom to downtown and open the building models layer attribute table. You'll use the Add Z information geoprocessing tool to add the highest Z to the building models attribute table. And last, you'll symbolize the building models by highest Z using graduated colors and the condition number color scheme. Back in ArcGIS Pro, I'm going to zoom back out from Petco Park and then frame downtown, looking west over downtown towards Coronado and the Pacific Ocean. All right, once I get it framed in my scene, now I want to open up my attribute table for my building model. So in the contents pane, I'm going to right click on building models and select attribute table. In my building models attribute table, notice I have the shape field that has the multi-patch geometry. I want to go ahead and add my highest Z values. So I'm going to use the Add Z Information Geoprocessing tool. So activate the analysis ribbon and click on Tools. In the geoprocessing pane, search for Add Z Information. And if I right click the item and select Locate, I can see that the tool is in the 3D analysis toolbox in the statistics tool set. Go ahead and click on Add Z Information. I set my input features to buildings_models. And for my output property, I want to select a statistical value of Z. In this case, I want the highest Z. So I'm going to check that and go ahead and click Run. Go ahead and close the geoprocessing pane. That adds the Z max field to my geoprocessing pane. And if I right click and sort in descending order, I can see by highlighting the first record where the tallest building is in downtown San Diego. Go ahead and clear selection. And in the contents pane, click on the symbol patch. In the symbology pane, under primary symbology, we're going to switch it to graduated colors. Make sure the field is set to Z max. And the color scheme, I need to enable show all. And if I click down a little bit, I'll find condition number. And so from green to red, I can see the lowest to the highest buildings in San Diego. That looks great. All right, go ahead and reset your view and save your ArcGIS Pro project. In step 4, you'll perform a 3D query. First, we'll reset the symbology and make building models selectable in the content selection panel. Then you'll orbit the scene to top down and select an entire building block with a 2D circle. Last, we'll orbit the scene down to street level or perspective and select the entire building block with a 3D sphere and compare the results. Back in ArcGIS Pro on the Quick Access toolbar, I'm going to click Undo a couple of times to reset my symbology back to the original symbology for building models. And now I'm going to use the Explore button and orbit the scene to nadir or top down and zoom in on Broadway Circle. Now I want to set building models as the only selectable layer. So over in the contents pane, I'm going to switch to list by selection and make sure building models is selected. Go ahead and flip it back to list by drawing order. And then in the selection group, I'm going to click on the select drop-down button and click on select by circle. So we're going to select by a 2D circle from the center of the block out and select the whole block and click one more time. And you can see we've selected 4 features. But that's because we performed a 2D selection. Go ahead and clear your selection. And with the Explore button, we're going to orbit back to street level perspective. And now I'm going to use the Select by Sphere tool to select from the top of the building. And again, frame the entire block and click one more time. And you'll see it only selects one building because I'm selecting in 3D and not in 2D. So you want to really make sure that you are aware when you're working in 3D if you need to perform a 2D or a 3D selection. Go ahead and clear your results. Reposition my view. I need to use the Explore button to do that. There we go. And go ahead and save your ArcGIS Pro project. In step 5, we'll perform a 3D sound, viewshed, and shade analysis for a proposed rock concert. We'll begin by creating a stage point feature class with our local state plane coordinate system in our project geodatabase. Then we'll add it to our scene, symbolize it as an ArcGIS 3D standing cube. Last, we'll edit the new stage feature class, add a point at our proposed location for our stage, and save our edits. Back in ArcGIS Pro, I'm going to use the Explore button to orbit our scene around to the waterfront. You can see there's Petco Park and the Convention Center and our venue where we're going to locate our stage. So I'm going to zoom in on that and orbit it around so I can see our proposed stage location with downtown San Diego in the background. All right, so now we're ready to create our point feature class for our stage. So I'm going to activate the catalog pane and expand my databases section, right click on project geodatabase and select new and feature class. In my create feature class wizard, I'm going to name my new feature class as stage, set the feature class type to point. I'm going to go ahead and leave Z values enabled and click next. I don't need any fields. Click next and confirm that it's our local state plane California coordinate system. Click finish. That creates our stops point feature class in our project geodatabase and adds it as a layer in the contents pane. Click on the symbol to open up the symbology pane, and under ArcGIS 3D symbols, select standing cube and then close the symbology pane. Now I'm going to activate an edit session by activating the edit ribbon and clicking on the create button. I want to make sure that my stage is my only selectable layer, my only editable layer, and I don't really have to worry so much about snapping because I'm not going to turn snapping on. And then in the create features pane, go ahead and click on the stage feature template and click on the point construction toolbar and then add a point at the location for the stage. And that adds our 3D standing cube symbol. Now that I've successfully added my proposed stage location, I'm going to clear my selection so I can see my symbol there. It's a little large, so I'm going to click on the symbol patch and in the symbology pane under properties, reduce the point size a little bit. Click enter. That looks a little bit better. Go ahead and close the symbology pane. Close the create features pane. And I want to save the edits to my stage point feature class and save my project.